let's take a look now at what our first derivative actually tells us about a function. So when we're looking at our first derivative, remember that tells us slope. So if f prime is greater than 0, if my slopes are all greater than 0, meaning they look like that, then I know that my original function is increasing. If f prime is less than 0, meaning if my slopes are negative or less than 0, if my slopes look like this, then I know my function itself is decreasing. And finally, if f prime equals 0, if at some instant I have a horizontal slope, then f is, I haven't really used this word before, but let's just call it stationary. It's neither increasing nor decreasing at that point. To find increasing and decreasing intervals, we have a pretty easy test for that. First, you find your critical points. And remember, critical points are where f prime equals 0 or it's undefined. Between these critical points, our function has the opportunity to change from increasing to decreasing or decreasing to increasing. Once we find those critical points, we put them on an f prime sign line. And then we can find our relative maxes and mins when f prime does change sign. So we'll do an example of that. I want to find where the function 2x squared e to the x is increasing and decreasing. And so remember, first we're going to find our critical points where f prime equals 0 or is undefined. To find that first derivative, you use product rule. I'll start by differentiating my first function, 2x squared. That derivative is 4x, and then e to the x stays unchanged. Then I add my first function unchanged, 2x squared, and then multiply by the derivative of e to the x, which we know is just e to the x. And I want to figure out where this derivative equals 0 or is undefined. Thankfully, I don't have any denominators, any square roots, or any natural logs in this function, so it's going to be defined for all real numbers. I'm going to set it equal to 0. And the easiest way to solve this equation, set equal to 0, is to factor. I'm going to figure out what these two terms have in common. I see that they have a 2, and an x, and an e to the x in common. So I'll factor that out. In this first term, if I pull out a 2x e to the x, I'm just left with a 2. And in the second term, if I pull out a 2x e to the x, I'm just left with x. Now I can set each of my terms equal to 0. So 2x e to the x equals 0, and 2 plus x equals 0. I know looking at this first term, e to the x never equals 0. So the only time this can equal 0 is if x equals 0. Here, 2 plus x equals 0 when x is negative 2. So 0 and 2 are 0 and negative 2 are my critical points. I'm actually going to erase this work now and put it, actually no, I'm not going to erase it because we need it. So I'm going to do my sign line up at the top. So here's my f prime sign line, and on it I'm going to put negative 2 and 0. The reason that I didn't want to erase this work is that I actually need my derivative, and preferably my derivative in factored form, to be able to test if these intervals are positive or negative. So let's start with my first interval, numbers less than negative 2. I'm going to pick negative 3. If I plug negative 3 into, right here, this derivative. 2x is negative. E to the x is always positive. Even if I plug in negative 3, it's just 1 over e cubed, which is positive. And 2 plus x, if x is negative 3, that's negative. Negative, positive, negative, I've got a positive interval, less than negative 2. Next, I'll plug in negative 1 for a number between negative 2 and 0. 2 times negative 1 is negative. E to the negative 1 is positive, but 2 plus negative 1 is positive. So we have negative, positive, positive. That interval is negative. And then I'll plug in a number bigger than 0, say 5. Positive for 2x, positive for e to the x, positive for 2 plus x. They're all positive, making that a positive interval. So I can now conclude using that f prime sign line that my function f is increasing from negative infinity to negative 2 and 0 to infinity. And f is decreasing from negative 2 to 0. And that's how you find increasing and decreasing intervals using your first derivative. I'm also going to note, I didn't ask for this, but I do have a relative max at negative 2 because I go from increasing to decreasing. And I have a relative min at x equals 0. So my function goes from decreasing to increasing.